In this video, we'll show you how easily we can slice a relief component in the software so that we can cut it out of a fairly thin piece of material. This will be with the intention of gluing the slices back together again to create one full thickness model. Okay, to get started with this tutorial, we're going to have a new instance of our software up and running. Let's create a brand new file. This is going to be a single-sided job, and the width of this is going to be 28 inches. The height will be 28 inches, and then our material thickness is going to be 1 inch. Now, this is good to remember the 1 inch thickness because this will be the maximum thickness that our slices can be, so it's good just to keep that in mind. We're going to zero off our material surface. Our XY datum will be set to the bottom left-hand corner. We're going to make sure that we choose a very high modeling resolution. That's because we're going to be using some 3D content, so we want to have all the pixels that we can have available to us. With our material settings, we're just going to make sure that we keep Canadian Maple set the way it is, and then we're going to go ahead and click OK. Now, of course, to get started with a slicing 3D model tutorial, we're going to need to have a 3D model. So let's go to our modeling tab and bring in a brand new 3D component using our import a component. We're going to navigate over to our tutorials folder and we're going to select the Apple edit.v3m file and then click open. And you'll see that in the bottom left-hand corner of your 2D view, we have our apple. Now we're going to need to make him a little bit bigger. So let's just go ahead and center him first. We can either press F9 on our keyboard to center the apple, or we can go back to our drawing tab and use this option right here, which is align selected objects. If I click that, I can choose this icon right here and it will center it to my material. And then I can click close. Now with that selected, let's scale it up to the right size that we need. So we're going to go back to our drawing tab and choose set selected object size. And we're going to make sure that our longest dimension, which is the height, should be 27 inches. We have our link XY checked and we have our auto Z scale checked. So we can just go ahead and choose apply and close this down. Now, the next thing we need to check is the thickness of our apple. So let's choose it and go to our modeling tab and have a look at our component properties. And currently right now, the shape height for the apple is set to 3.6393. Let's make this an even 3.75. And everything else is fine here. So we can just close that down. And let's tile our views and have a look at both the 2D and the 3D view. And then we'll twiddle around our apple to make sure everything looks okay. And I'm happy with that. So let's look back down on that again, then off click that. Now that we have a 3D component to start with, we can go ahead and move on to the slicing. So in our modeling tab, we'll take a look at the icon that's called Slice Visible Model into Individual Component Slices. So anything that we can see in our 3D view or our composite model will be included in this slicing operation. So let's go ahead and click that. Now this first bit of information in our form is just a review of what we've set up before. So our model thickness is going to be 3.75 as we'd set up before, and our material thickness, like we had set up when we first did our job, is set to 1 inch. Now this will be the maximum thickness of our slices that we can fit inside of this material if we plan on cutting it in this material or on this sheet. The next section is the model slicing. We have two different options here. We can choose our slice thickness or the number of slices that we'd like to have. If we decide to go with our slice thickness, we can enter the number in here. In this case, we have 1 inch, which will slice our model into 4 pieces. And the top slice will be 0.75 inches thick, which is thinner than our material thickness. So we'll have 3 slices that are exactly 1 inch and 1 that's the balance. Now we can choose to slice from top to bottom. And what this indicates is that the top slice will be 1 inch. So we'll have the top and the next 2 slices down from it will be 1 inch thick. And then the bottom slice will be the 0.75 inches thick. This might be helpful in the end if you want to have your top slice the full thickness of the material and then the bottom slice a variable thickness. We can also go ahead and tell the software that we want to have a number of slices. So in this case, if we choose that option, we'll see that we have 4 slices here. So it will take the shape height or the total thickness of our composite model and divide it evenly in 4 parts. So each slice will be 0.9375 inches thick. Now for this demonstration, we're going to go back to slice thickness and we're going to make sure it's set to 1 inch. and we're going to unclick from top to bottom, and then we're going to choose Set. You can choose to slice the model with the settings we just set, but also we have extra control in case it is needed. Sometimes the initial setup will give you results that may cause you extra work in assembly. For example, extra parts or islands, thin areas or areas that have holes. Another thing to consider is that you may want to use different thicknesses of material in a multi-sheet project. Having unlimited control of slice thickness may be beneficial in a lot of cases. Now let's go ahead and have a look at our slice height section of our slice model dialog. This colored bar on the left-hand side represents the full thickness of the material, and the horizontal lines indicate the top of each slice. Red indicates the selected slice, where green is the accumulated thickness of all the slices above the selected slice, and the gray is a reflection of the accumulated thickness of the slices below the selected slice. These are reflected in your 3D model. Green being your top slice in this case, red being our selected slice, and then gray being the accumulation of all the slices below the selected slice. From this area, you can choose the different slices. The bottom slice, the second slice, third slice, and then your top slice is indicated in green. It's important to note or to realize that you have this information down here below. You have your slice thickness, and that's the slice thickness of your selected slice, and then the thickness of your top slice. Now these will change, and so it's good to keep an eye on them as you go ahead and modify the slice thicknesses. There are several different ways to change the thickness of your slice. You can use this dialog right here, and then choose Apply, and you'll see that your slice bar is updated along with the 3D preview of those slices. And then also your slice thickness, and then the top slice thickness is changed as well. Let's put that back down to 3 again. Hit Apply. Now I can also go ahead and with inside of the slice above my selected slice, so in this case the green area, I can double click and dynamically choose the area or the top of the selected slice. Just be careful that you don't cross over into another slice, like this for instance, without meaning to. And you'll see that my slice thickness bar now is looking a little bit strange and not exactly what I wanted. So I can go ahead now and choose and set this back to the basic settings I have up here. Now if I want to, in the 3D view, I can adjust the selected slice thickness by holding down my Shift key and my mouse wheel on my mouse. And again, I can adjust the top surface of the selected slice and where that's going to end up being in my composite model. This is really helpful for making small adjustments so you can avoid trouble areas. And I can go back and set that again back to the way it was originally. Now if I want to remove a slice, I can just select it out of my list and I can go ahead and choose Delete. If I'd like to add in a new slice, I just need to type in the top thickness of the slice and then click New. Or if I want to start from scratch, I can go ahead and click Clear and remove all of my slices and then start manually adding them in. Before we move on, it would be good to point out some of the things that we can do directly on the slice heights bar. While it's clear right now, I can double click anywhere on the bar and add in the slice. If I want to add in a slice in the center of this slice, I can just go ahead again and double click in there. If that was a mistake, I can then double click on that horizontal bar that represents the top of the slice I'd like to get rid of, and I can double click that as well. I can add in a couple more slices, and then if I want to choose this slice below this horizontal line, I just need to click that actual horizontal line. Now if I'm happy with my custom settings, then I can go ahead and move on to the next section. But for right now, we want to go back up here and reset this back to our original setup, and then move on to the next section. Create boundary vectors. When you have this option checked, the software automatically generates bounding vectors for every slice, including any areas that are flat as a result of the slice being equal to the material thickness. In case you forget, we have a nice little tooltips box here to remind you of all the tools that you can use directly into the 3D view. Now let's go ahead and slice our composite model. And note in the 2D view, as the slices are being created, we get the vector boundaries and also new bitmap representations of the slices. As you can see in our component tree, we have 4 new components: slice 1, slice 2, slice 3, and slice 4. And then in our layers manager, we have 4 new layers: slice 1, slice 2, slice 3, and slice 4. Now on the slice 1 layer, we have the vector boundary for the slice, and then we also have the sliced component on that layer. So we don't need the apple anymore, so let's select that, right click on that, and we are going to delete that. And we also don't need the layer that it was sitting on, so let's bring down our layers manager and we'll right click on that layer number 1, and we'll delete this layer. So now we're left just with what we need to work with. Let's just go ahead and show only slice number 1. So let's right click on that, and we're going to go down to show only this. And in our layers manager, we'll pop that down. We'll hover over top of slice number 1, and we'll go down to show only this. Then we'll click out of that. Now you'll see we have the slice here, and we also have the boundaries that were created when we told it to create boundaries for each slice. We have the internal boundary, and that encompasses the flat area. That's the surface of the 1-inch slice. And then in between the 2 boundaries, we have the 3D area of our slice already isolated for us, ready for tooling. And that's the same for each of our slices. Now if we take a look at the component properties for this slice, you'll see that it's set to 1 inch, and that's what we asked it to do. And so all of the slice 1, 2, and 3 should all be 1 inch. And if we look at slice number 4, you'll see that it's not 1 inch. It should be 0.75 of an inch with that selected. And also we only have 1 boundary because there aren't any flat areas that are going to touch the surface of our 1-inch material. So we just have that 1. Let's go ahead now and turn those all back on again. Slicing the part in a job size that is a bit bigger than our component has enabled us to maximize the model quality for each of these slices. Now we need to increase the job size so that our job size will be the size of the actual material that we are going to be cutting this project in. That way we can position all of the slices and get ready for machining. Okay, to increase our job size, let's go to our drawing tab and we're going to click our job dimensions. Let's change this to be 48 inches by 48 inches, and everything else we're going to leave the same, and then we'll click OK. Now to get started, we're just going to manually position these slices where we'd like them to be. So we're going to hold down our Shift key and we're going to select the top slice and then its vector boundary. Click again and we'll drag it up to here. In the next slice, we'll grab that slice, hold down our Shift key, and we're going to select its boundary vectors. We'll click it again and then we'll move it over here. We'll do that with our next slice. We'll select the slice, hold down our Shift key and grab its vectors, and then we'll click there and bring it up there. In this case, we're going to rotate it around to about there, and then we're going to bring it down and just kind of fit it in there the best we can. We need to make some minor adjustments here just to get everything so there's a bit of a gap between everything. And let's have a look at that. Now I think we best suited if we went and made sure there was 1 inch of white space all around all of our components. So to do that, we're going to move these, but move them accurately using our tool here called Move Selected Objects. So let's select this apple slice, hold down our Shift key and grab that set of vectors, and we'll go ahead and move those. So we'll make sure that we use our anchor point. It's going to be the bottom left-hand corner. Our type of move will be absolute, and we're going to move it to a position of 1 and 1, and we'll click Apply. And you'll see now it's moved over to be 1 inch from the edge of the left and the bottom hand side. Now let's go ahead and hold down our Shift key, and we're going to go ahead and click this other slice and its vectors. We're going to go ahead and make sure that we use the bottom here as an anchor point, and we're going to change this to be 47 and 1 and click Apply. Let's do the same with this slice here. We'll select it and hold down our Shift key and grab its vectors. And we're going to make this top corner, top right corner. We'll make it 47 and 47 and click Apply. And this one here has got ample space around it, so we'll leave it just the way it is. I think what we might want to do is rotate this guy just slightly so we have a better gap between the two. So let's select that, hold down our Shift key, grab our rotational handles here, And just turn that a little bit, and then we'll move it back to where it was a second ago, which will be 47 and 1, and click apply. And that's great. Before we go too much further, we should have a little think about how we're going to machine this. Depending on our material that we're going to be using, we're going to have a lot of choices to think about. First of all is how we are going to fix this down to our CNC table. Currently, right now, a lot of these components come right down to the bottom of our material. There are a few areas that don't, so we could add tabs into those areas, but the rest of these, if we did add tabs, would cause us a lot of handwork in the end to remove those once we took them off of our CNC. We could consider maybe marking the tops of these flat areas with a V-bit, and then we could screw these down to our table in the center where our cutter will never get close to, and then when we're all done, we could go ahead and remove them that way. But that still leaves us an issue with our top slice where it comes down and it's very thin. We could try double-sided tape, but even still, that might not be safe enough. After we consider all that, we also need to think about how we're going to reorganize our vectors so that we can have the right ones to do the right job. So for now, I think our best bet is going to be to add in a zero plane, give it a slight base height, and then when we go to run our cutout passes around these, we'll end up having a bit of a lip. The benefit of that is that that zero plane and its base height, it will add what we call an onion skin between our parts and our actual waste material, and it'll hold it in place until we get around to cut those out. So let's go ahead and do that. Let's go to our modeling tab and over here to where we can add a zero plane in. When we click that, you'll see that in our 3D view, we have a zero plane added in. We have a new component here in our component tree called zero plane. And in our layers manager, we have a zero plane, but you'll see that it's turned off. Now we're going to go ahead and add a base height to this. So with that selected, let's go to our component properties and add a slight base height to that, 0.03. Press the spacebar to accept that, but we're also going to need to turn this to a merge component because right now it's being added to everything. So all of these have gotten thicker by that 0.03 of an inch. So let's go ahead and merge that in instead. And then we're going to go ahead and close that down. And you'll see how that runs into the edge of this top slice. And if I hide it and show it, it does cover up part of the component, but we'll have this flat edge when we go to cut these out. But when we assemble our parts together, we can easily just sand those out, assuming that our material is easily manipulated like that. Okay, that's great. Now let's make some adjustments to the vector boundaries. We're going to maximize our 2D view, and we're going to press F on our keyboard to fit that to screen. Each set of vectors was grouped and placed on a particular layer when we sliced the apple. So I'm going to ungroup all of those vectors and then regroup them in a specific order. So let's select this one here, right click and ungroup. Select this one, right click and ungroup. Select this one here, right click and then ungroup. And this one is only a single vector, so we don't need to ungroup anything there. Now we're going to select all the outer vectors. Holding down our shift key, we'll grab them all. These we're going to use to profile cut out our parts in the end. So we're going to right click on those and then we're going to group those together. Now let's select all of these internal vectors and we're going to go ahead and group those together. And these are going to be used to help us to isolate our tooling to only cut between the profile vector and the flat area of our components so that we can optimize our tooling. We don't want to cut all of these flat areas with our 3D Toolpath. That would take a lot of extra time. We don't want to do that. Now also we're going to take this outside set of vectors and we're going to offset these out slightly so that when we do our 3D tooling, that finishing cutter will actually go off the edge of our model and end up giving us a nice clean edge all the way around and get all of our 3D detail that we want around the edges of these parts. So to do that with that selected, we'll go to our drawing tab, we'll choose offset. We're going to offset outwards. We're going to offset out about 0.03 of an inch. It's a little over half of the diameter of the half-inch tool we're going to use to do our finishing pass. We're not going to create sharp corners. We are going to not delete the original, and then we're going to select the new ones. Offset those outwards. Then we're going to right click on those and then we're going to group those together. So now we have our 3 sets of vectors that we're going to need to do our tooling. So let's close this down and let's go over to our Toolpath tab. We're going to start off by having a look at our material setup. So we're just going to click Set here. Start at the top and we'll work our way down through the form. Our material thickness is 1 inch. Our XY data will be set to the bottom left-hand corner. Now we're going to zero off our machine bed this time. If we decided to zero off our material surface, then if there happened to be a low point where we zeroed off our machine, then that 0.03 of an inch of zero plane that we added in may get lessened, and we want to keep as much of that as we can. So if we use our machine bed, then we're pretty sure that we're going to get the right measurement, and that should stay pretty consistent all the way through. When we talk about our model position and material, we're going to leave it just as it is. Nothing will change there. And we're going to make sure we set our rapid Z gaps and our home start position so they're safe and appropriate for your machine. Then we'll just click OK. Now the first thing we're going to need to do is develop a roughing pass. So let's go ahead and click on that. And to create a roughing pass, we're going to need to choose these 2 sets of vectors. So the outside offset set that we created earlier, and then the inside one. So we have those 2 selected. We're going to be doing our 3D tooling between these 2 sets of vectors. We're going to choose our tool. So let's select our 1/2 inch ball nose. Now, typically we'd use an end mill for roughing, but because we don't want to make any tool changes, we're going to go ahead and use this same bull nose all the way through all 3 of our tool paths. So we're going to select that, and we're going to leave our step over and pass depth and all that as it is right now, and we'll select that. But now for this particular tool path, we're going to temporarily edit those settings. So let's go in and edit those now. And we are going to change our step over percentage to be 40. Now, typically we'd be using a bull nose for a finishing tool path, but seeing as we're going to use as a roughing tool path, we can be much more aggressive with these numbers and we'll be okay. So we'll just select OK. We're going to make sure that our machine limit boundary is set up to between vectors. So we're going to use our selected vectors, which again are these 2 sets of vectors that we have. We're going to have a boundary offset of 1/4 inch. We're going to leave a little bit of material behind so we can come back with our finishing bit and get rid of that. So that's 0.04 of an inch. We're going to use our Z-level roughing strategy. We're not going to worry about any ramp or plunge moves, and we're just going to rename this 3D roughing, and we'll click calculate. Perfect. Let's preview our visible toolpath. Make sure that we get what we hope we're going to get in the end. And that looks exactly right. That's perfect. Wonderful. Okay, so let's just close that down. And let's go on to our 3D finishing toolpath. Now we're going to remove this 1/8 inch ball nose out of here. So let's remove that. Then we're going to go in and select that 1/2 inch ball nose again. We'll just select that. We're not going to edit those settings because they are set up for a finishing pass with this particular tool. If we look at our 2D view, you'll see that we have that same set of vectors selected, so that's perfect. We're not going to have any boundary offset. We are going to use the offset tooling, and we are going to just rename this 3D finished, and we'll calculate that. And let's preview our visible toolpaths. And there we go. That cleans up really nicely in the end. That's great. The last toolpath we're going to need is a profile toolpath to cut our apple slices out of our material. So let's go ahead and select that. Our start depth is going to be at 0. We're going to cut down through the full material depth. So it's going to be 1 inch. Again, we're going to reselect our tool and we're going to go back to that 1/2 inch ball nose and we'll select that. We're going to go back to our 2D view and make sure that we just have this inside vector selected, or set of vectors. That's going to be our profile vectors. We're going to cut outside of that. We're not going to have any ramp or plunge moves. We are going to add in some tabs. Let's go ahead and select that. And you'll notice that the tabs that I have set up here, the length is quite long, but they are very thin. They're only as thin as that base height that we added to our zero plane, which is 0.03. We'll edit those, and I can add those in wherever I want. So I can just go ahead and click on that vector, that profile vector, and I can add one in. I can delete one out if I'd like to. Just position them wherever you think you need them. That all looks great, and we're just going to click close. And we're going to go ahead and rename this cutout, and then we'll calculate that. And we'll preview our visible toolpaths. And there you'll see that we get our tabs right here, But then we cut down right to the bottom of our material. And you can't quite tell that here, but we'll have left is a little bit of material here that we're going to go ahead and need to remove once we cut this out of our waste material. But those tabs should hold those parts into place. Now at this point, you can go ahead and save off your toolpaths and run them. If you're interested in how to do that, you can take a look at our toolpath saving guide, and I'll link to that in the related videos below. Let's just close this down. Let's look straight back down on our setup.